Welcome to this comprehensive guide on packaging and exporting builds in Visual Studio and Unity 3D, designed specifically for beginners. This tutorial will walk you through each step, ensuring you gain a solid understanding of how to prepare your projects for distribution, whether you're developing applications with Visual Studio or games with Unity 3D. We'll cover everything from initial project setup to final export, providing practical insights and best practices along the way. We'll cover essential steps and helpful tips to ensure your projects are correctly prepared and exported for distribution. Our goal is to demystify the build process, making it accessible and straightforward, even if you're new to software development or game creation. You'll learn how to avoid common pitfalls and optimize your workflow for efficient project delivery. First, let's begin with Visual Studio, focusing on the crucial preparation steps before initiating any build process. Understanding these preliminary configurations is key to a successful and error-free build. We'll delve into how to set up your project environment correctly, ensuring all necessary components are in place before compilation begins. It's vital to configure your project for a release build, which optimizes performance and reduces file size compared to debug builds. A release build is compiled with optimizations enabled, stripping out debugging information and making your application run faster and consume fewer resources. This is crucial for applications intended for end users, as it provides a more polished and efficient experience. Access the Configuration Manager through the Build menu to switch from Debug to Release for your active solution configuration. This manager allows you to define different build configurations for your projects, such as Debug for development and Release for deployment. Selecting Release ensures that your application is compiled with the appropriate settings for optimal performance and distribution. Ensure all project dependencies are correctly referenced and included. Missing dependencies are a common cause of build failures. Dependencies can include external libraries, frameworks, or other projects within your solution. If these are not properly linked, the compiler won't be able to find the necessary code, leading to errors and an incomplete build. Double-checking these references is a critical step in preventing compilation issues. Right-click your project in Solution Explorer, select Add Reference, and browse for any necessary assemblies or packages. This process allows you to explicitly tell Visual Studio where to find the external components your project relies on. Whether it's a NuGet package, a custom DLL, or another project in your solution, adding the correct reference ensures that all parts of your application can communicate and compile successfully. Before building, always clean Solution to remove intermediate files from previous builds, preventing potential conflicts. Over time, temporary files generated during the build process can become outdated or corrupted, leading to unexpected errors. Cleaning the solution ensures that you start with a fresh slate, eliminating any lingering artifacts that might interfere with a new build. This step ensures a fresh build, incorporating all recent changes without interference from old compiled assets. By removing all previously generated build artifacts, you guarantee that the compiler processes only the most current version of your source code and resources. This practice is essential for maintaining build integrity and resolving stubborn compilation issues that might arise from stale files. Now, let's proceed to the actual build process within Visual Studio, transforming your source code into an executable application. This is where all your carefully written code and configured settings come together to produce a functional program. The build process involves compilation, linking, and packaging, ultimately creating the files necessary to run your application. To build your project, simply go to the Build menu and select Build Solution, or use the shortcut F6. Initiating the Build command will trigger Visual Studio to compile all projects within your solution according to their configured settings. The output window will display the progress, indicating whether the build was successful or if any errors occurred during compilation. Upon successful completion, your compiled application files will be located in the Projects bin/release folder. This directory typically contains the executable file, along with any necessary DLLs, configuration files, and other assets required for your application to run. It's important to know this location for testing your build and preparing it for distribution. If you encounter errors, the Error List window in Visual Studio provides detailed messages and locations to help you troubleshoot. This window is an invaluable tool for debugging, as it pinpoints the exact line of code or configuration setting that caused the error. Understanding and utilizing the error list effectively will significantly speed up your debugging process. Common issues include syntax errors, missing references, or incorrect project configurations, all resolvable with careful review. Syntax errors are often typos or incorrect code structures, while missing references mean your project can't find a required component. Incorrect project configurations might involve targeting the wrong platform or framework. Addressing these issues systematically will lead to a successful build. Next, we transition to Unity 3D, where the process of building and exporting games or applications differs significantly. Unity's build process is tailored for game development, focusing on packaging assets, scenes, and scripts into a playable format for various platforms. While the core concept of compilation remains, the steps and considerations are unique to the Unity ecosystem. Before building in Unity, ensure all scenes you wish to include are added to the Build Settings window. Only scenes listed in this window will be part of your final build. If a scene is not included, it will not be accessible in your compiled game or application, potentially leading to missing content or functionality. This is a common oversight for beginners, so always double-check your scene list. Go to File, Build Settings, and drag your scenes from the project window into the Scenes in Build list. The order of scenes in this list is also important, as it determines the loading order in your game. Typically, your main menu or initial loading screen scene should be at index 0. You can reorder scenes by dragging them up or down within the list. Select your target platform, such as PC, Mac and Linux standalone, Android, or WebGL from the platform list. Unity supports a wide array of platforms, and choosing the correct one is the first step in tailoring your build. Each platform has specific requirements and optimizations, so selecting your intended deployment target early on is crucial for a successful build. Each platform has specific settings that need to be configured, impacting performance and compatibility. For instance, building for mobile devices like Android or iOS will require different texture compression settings and API levels compared to a desktop build. These platform-specific adjustments ensure that your game runs optimally and is compatible with the target hardware and operating system. In player settings, accessible via Build Settings, configure aspects like company name, product name, icon, and resolution. These settings define how your application appears and behaves on the target platform. For example, setting a unique product name and company name is essential for App Store submissions, and choosing an appropriate icon provides brand recognition. Resolution settings allow you to control the default display size of your application. For mobile platforms, ensure correct bundle identifiers and API compatibility levels are set for successful deployment. The bundle identifier, often in a reverse domain name format like com.yourcompany.yourgame, uniquely identifies your application on app stores. API compatibility levels dictate which versions of the operating system your app can run on. Incorrect settings here can lead to rejection from app stores or runtime issues on user devices. Once your settings are configured, click the Build button in the Build Settings window. This action initiates the compilation and packaging process, where Unity gathers all your assets, scripts, and scenes and transforms them into a playable application for your chosen platform. It's the culmination of all your preparation steps. You'll be prompted to choose a destination folder for your build. Create a dedicated folder to keep your project organized. It's good practice to create a new folder, perhaps named Builds or Exports, outside of your main Unity project folder. This prevents your project directory from becoming cluttered with build artifacts and makes it easier to manage different versions of your compiled game. Unity will then compile your project, which can take several minutes depending on its size and complexity. During this time, Unity processes all your assets, compiles scripts, and packages everything into the final build. For larger projects with many assets or complex scripts, this process can be quite time-consuming, so patience is key. A progress bar will indicate the current status of the build. After the build completes, navigate to your chosen folder to find the executable file and associated data. For a PC build, you'll typically find an executable and a data folder containing all your game's assets. For other platforms, the output might be a different file type, such as in .apk for Android or a project folder for iOS. This is your final, playable application. Test your build thoroughly on the target platform to ensure everything functions as expected and there are no runtime errors. This is a critical step, as issues might arise in a compiled build that weren't apparent in the Unity editor. Check all functionalities, user interfaces, and game mechanics. Testing on actual target devices is highly recommended to catch platform-specific bugs. For distribution, you might need to package your build further, especially for app stores or specific deployment scenarios. Simply having the executable might not be enough. For example, app stores often require specific metadata, screenshots, and sometimes even a different packaging format than the raw build output. Understanding these additional packaging requirements is crucial for successful deployment. In Visual Studio, for Windows applications, you can create an installer package using tools like Wix Toolset or Microsoft Installer Projects. These tools allow you to create a professional-looking installer that guides users through the installation process, handles file placement, and manages dependencies. This provides a much smoother user experience compared to simply providing an executable file. These tools help bundle your executable, dependencies, and resources into a single, user-friendly installation file. An installer ensures that all necessary components are correctly placed on the user's system, registers your application if needed, and provides an easy way for users to uninstall the software. This professional packaging is essential for commercial applications. For Unity, exporting to mobile platforms often generates platform-specific project files, like an Xcode project for iOS or an Android Studio project. These are not the final deployable applications, but rather intermediate projects that need further processing. Unity acts as a powerful content creation tool, but for mobile, it often hands off the final compilation and signing to the native development environments. These projects then need to be opened in their respective IDEs for final compilation and signing before submission to app stores. For iOS, you'll use Xcode to build and sign your app with an Apple developer account. For Android, Android Studio is used to generate a signed APK or AAB file. This signing process verifies the authenticity of your application and is a mandatory step for App Store distribution. Always keep backups of your project files before making significant changes or attempting a build. Data loss can be devastating, and regular backups provide a safety net. Consider using cloud storage solutions or external hard drives to store multiple versions of your project. This simple practice can save you countless hours of work if something goes wrong. Version control systems like Git are invaluable for tracking changes and reverting to previous states if issues arise. Git allows you to manage different versions of your code, collaborate with others, and easily roll back to a stable version if a new change introduces bugs. Learning Git is a fundamental skill for any serious developer, providing robust project management and safety. Regularly update your Visual Studio and Unity installations to benefit from the latest features, bug fixes, and performance improvements. Software updates often include critical security patches, new tools, and optimizations that can significantly enhance your development experience and the quality of your builds. Staying current ensures compatibility with the latest operating systems and hardware. Stay informed about platform-specific requirements and guidelines, as these can change frequently, especially for app stores. Apple's App Store and Google Play Store frequently update their submission guidelines, technical requirements, and content policies. Keeping up to date with these changes is essential to ensure your applications are approved and remain compliant, avoiding unnecessary delays or rejections. Remember, practice makes perfect. The more you build and export, the more familiar and efficient you'll become with the process. Each build you complete, whether successful or not, provides valuable learning experience. Don't be discouraged by errors. Instead, view them as opportunities to deepen your understanding and refine your workflow. Consistent practice will build your confidence and expertise. This concludes our detailed guide on packaging and exporting builds in Visual Studio and Unity 3D. We've covered the essential steps, from initial project configuration to final deployment considerations, providing you with a solid foundation for managing your software and game projects. We hope this comprehensive overview has clarified the complexities of the build process for you. We hope these step-by-step instructions and tips empower you to confidently prepare and deploy your projects. By following these guidelines, you'll be better equipped to handle the intricacies of building for various platforms, ensuring your applications and games reach your audience smoothly and professionally. Your journey into successful project deployment starts here. Thank you for watching, and happy building! We encourage you to experiment with different settings and platforms to further enhance your understanding. Don't hesitate to revisit this guide whenever you need a refresher or encounter new challenges. Best of luck with all your future development endeavors.